And again, you can go back and finish the right one here in just a minute. It says, write the standard form of the equation of the line through the given points. Now, we have one of them that's a special point. Anybody recognize it?
It's the y-intercept.
How do you know that, Jack?
Because the x is 0.
Everybody in the room should be able to look at a point like that and know it's the y-intercept. It's very, very basic. All you need to say is x is 0, therefore it's on the y-axis. End of story. So good job for having that. But again, if that wasn't you, make sure you're going back and reading this stuff, guys. This is high school. High school builds and expects you to know stuff from prior sections. So if that requires you to study your notes a lot, then do it. You'll need to have that knowledge as we go forward. I'm going to work this problem as if we don't know the y-intercept, just so you have an example of when you don't get the y-intercept provided, like number 2. Just know that we were given it that time. First step is to find the slope. And maybe for that, remember we went through and labeled this is XA and YA, XB and YB. And then we plugged it into this little equation to find slope. And just to remind you of a couple cautions, y is always on top. Even if we're given a table where x and y are like this, even though y is in the bottom on the table, it still goes on top in your when you're finding slope. Second caution, make sure that the x and y's go together. Like B comes first, then A, and we don't mix one of the two, like top or bottom up. So in this case, YB is 5, YA is -2, XB is 0, and XA is -3. And you definitely need to make sure to capture all those negative signs, all the subtraction and negatives. Okay, 5 minus -2 is 7. 0 minus -3 is 3. So 7/3 is our slope. It's kind of ugly. Oh well. At this point, you can choose to use either slope-intercept or point slope. Oh, that's x, sorry. X minus x1. And in this, I put the 1s because that's how you'll usually see it, but that's either x and y, A or B. In other words, pick a point, that's all. I am very much more fond of point slope, so I'll run it that way. You can do the other way if you want to. What is y1 or ya or yb? What is, in this problem, what is that? So we just pick a point. Pick a point, Jasmine. Let's use point, huh? Yep, all right, so -2 is A, is YA, I mean. And then our slope was 7/3. Somehow I lost the 3. And then we say x minus x1. What x coordinate goes with this y coordinate of -2? What x coordinate goes with it? That one right there, -3. It has to be the one that is with the -2. Okay, so this is not standard form yet. Let me go ahead and clean some stuff up. Okay, how did I get 7/3 x and 21/3? Where did those come from? Yeah, so to get rid of those parentheses, we just distributed the 7/3. And right here, minus negative is really plus. And same thing over here, minus -2 is really +2. So that's where that came from. Okay, and then if you recall, in fact, let me show you in your notes, the last example we actually put in there, there we go, was how to get standard form from an equation that we have that's not in standard form. So the steps are over here on the right. Standard form looks like this, ax plus by equals c. It says get x and y on the same side. Okay? So let's just take this step by step. And if you notice, I have this 7/3 x on the right. I want it over there with the y. So how do I do that? We want x and y together on the same side. How do I get the x over there? Yeah, for now, we're just going to leave it as 7/3. We're going to subtract it from both sides, 7/3 x. You know what? Let's go ahead and clean up 21/3. What is 21/3? Is 7. Okay, so equals 7. All right, we're kind of getting there. Note say, next step. A can't be negative or a fraction. So how do we do that? Well, let's get rid of this 2 because it doesn't belong over there. So we'll just subtract 2 from both sides. And it's looking really close to standard form now. But like our notes say, we can't have a negative a value, and it can't be a fraction. So we want to multiply by something to get rid of both the fraction and the negative sign so that it's not that way. What would we multiply by? Yeah, good job. So let me show you what the notes say. So multiply by the denominator of a. Well, a right now has a 3 in the denominator. And then also as needed by a negative if we need to make it positive. So like Abby said, if we multiply this by -3, it's going to take care of both issues at the same time. So we're going to distribute that -3 all the way across. And you guys tell me, what do we get for the x now? Like in front of x, I mean. What do we get? What does this -3 do to that 3? Yeah, those cancel. That's why we did it. It also cancels the negative sign. So we get 7x. Okay, and then what about this next one? The -3 onto the y. What does that become? -3y, and then how about on the other side of the equal sign? -15. So that is nice, pretty standard form. Now, we could have done the whole thing if we had gone first to slope-intercept form. And the difference for me, the reason I don't like it as much is because you end up having to solve for b. And sometimes that doesn't go well. Here we just plugged in a point, and you always have a point, otherwise you're not writing an equation. All right, so give that second one a chance, or a shot, I mean. And why do I have 2 things right there? And maybe just a few minutes on that second one, and then we'll check, and then we're going to start talking about our main goal for today, which I'll tell you when we get there. So I'm just going to sort of sketch. This is kind of our line. It's like both x coordinates are 2, so it's a vertical line. So in standard form, it's really just that point right there, which is the x-intercept. So our equation is going to end up just saying x equals some number. Can you tell me which number it is? Like, what are all the x coordinates of all those points is really what we're boiling it down to.
Oh, okay.
Which is what?
On yours isn't it zero?
Well, I meant like, what's the x coordinate of that point and the one I added in there? What is the x coordinate for all of those? Or any other, actually. Like any point on this line always has the same x coordinate.
That doesn't make sense. I'm confused.
Okay. Well, like, let's say this is the point 2, 3. What would those coordinates be? Roughly. Like, just make some up that makes sense.
I don't know.
Well, like the coordinates for that point are 2, 3. What would that one be?
1, 2.
Well, it's still
Yeah.
over 1, 2. It's still 2 over.
Oh,
So 2 what?
oh, 2, 2, 2.
2, 2. Okay, how about that point?
2, 1,
That point?
2, 0.
Do you see a trend here?
Yeah,
What are we writing every time?
2.
This is our 2, -5. So what is always the x coordinate going to be?
2.
2. So our line is just that in this case. And the reason why is we don't have a slope because it's vertical. I'm going to talk more about it up here, but all right, check it out. This one, we start with slope. This one's kind of weird. So XA, YA, XB, YB. So we get 8 over 0. What kind of line is that?
Undefined. Straight or no solution.
Ella and Jesus are like, it is not, well, straight line, all lines are straight. 2, it's not an undefined line, but the slope is undefined, right? Right? Okay. So we wrote about this in your notes. I just want to point this out.
Constant.
And let me see where, so I can remind you where to look. All right, well, never mind. Put it in there. Everybody grab your notes. I thought we did. Maybe it's somewhere else and I'm just not seeing it right now. Yeah, there it is. It's actually in there. It's in the example section instead of the vocab section. So, special lines. Which one of these two special lines is this one we just worked on?
Slope equals 0.
Slope is undefined.
It's an undefined slope, right? It's this actually this same idea. It's 8 over 0. Is there a reason we're talking right now? Or doing whatever that is? Turn around. It's actually this case, right? It's for some reason it's the same numbers. We just happen to get lucky. But 8 over 0. So that's undefined. So what kind of line is this? It's a vertical line, right? It's a vertical line. And remember, If it's a vertical line, our equation for that line is just x equals whatever number it goes through. So back to our current example. If you sketch a little graph of this, we have a point there and a point there, as well as every other point on this vertical line. What are the coordinates, the x coordinates that it goes through? Or what is the x coordinate it goes through? It's 2. So our equation for this one is just x equals 2. There is no bx because there's no slope. It's not zero slope, it's just undefined. Okay? So in standard form for a vertical line, it's just x equals. In standard form for a horizontal line, it's just y equals. Okay? If you have done a good job on writing this problem out, please write this as a reminder. This is undefined slope. Therefore, it's a vertical line. Now, this is going to be important to lead us into what our next topic is, which is really all about slope, or largely about slope. Did anybody get that one, by the way? Job. Is it better now?
Yeah.
Okay. Uh-huh.
I got the other one.
Can I go to the bathroom just like?
Okay. So we're going to pull this into our last section for Unit 2. Any idea what these two symbols mean? Okay, I'm not going to tell you right now. I'm going to come back and tell you after we've done a little investigating. So we started with this last week. Some of you did. Some of you are still finishing up your tests. And what we ended up doing was graphing, like the 3 black lines were given, and then we graphed three additional lines on there. And our goal was to kind of analyze what kind of lines those were. So to save time, I put them on here. And what I want you to do, it kind of looks messy when they're all together. Here's what I want you to analyze. Take lines in pairs. So do you see lines that might go together in here? You'll pick a colored line and a black line. Like that's what I'm saying in terms of pairs. Like what line looks like it probably goes with the red one in terms of pairs? Okay, yeah, and we have names on here. Red and which one? And B, why? Yeah, let's make that stand out. They are parallel. What does parallel mean to you? Yeah, Levi?
They keep on going and they don't intersect.
They don't intersect. And they're beside each other, okay? Good, those are actually true. As long as they're in the same plane, meaning they're both on the XY coordinate plane and not some other plane, okay? Good. Well, what is the slope of the red line, which is this top line? Let me get rid of the highlights. I think it'll be easier to see it. So let's pick these 2 points right here. What's that slope? Up to, oh, that's not a 2. Up to, and what? Over 3. All right, let's check out these 2 points on line B. So again, what's the slope between them? Up 4 over 6, which reduces to 2 over 3. Okay, so what would you describe in terms of slope of these 2 parallel lines? Same slope. Let's see if that holds true for another pair. Okay, let's do the green line and line C. So we're going to go here. What's the slope between those 2 points? Down 3 over 1 to the right. Okay, what's the slope between those 2 points? Yeah, that was kind of nice because they're so close together. All right, so are you seeing the trend? From here on, meaning into geometry class, you'll use it there. Maybe algebra 2 well, I don't know if you're going to go on from there, but potentially in calculus you might use it. What are we going to say about parallel line slopes forever? They are what? They are the same. Okay, I heard useful. That's also true. Go to your notes. We're going to put this in here. Big bold. Okay, so these kind of questions come in various forms. Maybe I tell you I show 2 lines and I say, are these lines parallel? So you would need to check their slopes, kind of like what we just did. Maybe I give you some points and say, write an equation for this line and a line parallel to that line. Okay, and so same slope is the big idea here. Otherwise, we're just writing equations of lines or analyzing. However, you need this caution. Make sure to reduce fractions completely. Because we just saw that happen. We had, on the first set of lines, we had 2 and 3, and then the next one was 4 and 6. And we wouldn't have necessarily known they were the same if we didn't reduce. So before you compare, make sure you do that. Or I suppose if you're just checking if they're parallel, you could just divide the fractions to a decimal and make sure that's the same. That's another option. So same slope. What other kinds of lines, special lines, do we have?
Exponential.
Well, that's true. We'll study that in probably around March. Maybe a little before that.
Intersecting lines.
We'll study that under years.
They are intersecting, but at a right angle. Anybody know what those kind of lines are called? I'm glad you're making up stuff. By the way, the symbol for parallel lines is just 2 parallel lines. Sometimes they do them vertically when they're printed, and it looks kind of like an 11. So when I do mine, I usually do them diagonally a little bit so it's not confused. But the symbol for parallel is just 2 parallel lines. Makes sense, right? Okay, so the other kind of, don't draw this on your notes. The other kind of lines that we might be talking about are like the X and Y intercepts, or axes. What are those called? It starts with a P also. You guys haven't heard of it. Okay, these ones are called, I'm going to skip a box. So tell me when you know the word.
Perpendicular.
Yeah, good job.
Of course I did it.
Okay, the symbol for that one
I said 0.
is just perpendicular lines. It looks like an upside down capital T, but it stands for perpendicular. And specifically, we're going to define these. I think you don't have as probably good a definition as these. Yeah. We're taking notes. Like, I don't know why you want to miss that, but sure. Perpendicular is 2 lines that intersect at a 90-degree, which is called a right angle. Do you come across perpendicular lines in your life?
Yes.
Name some.
This.
What about it?
It. Like. The counter goes this way, but the edge goes this way.
Okay. So the front edge of your counter versus the surface. What else? Good job. You're right. What else? What are you pointing at? What about it? I'm not saying you're wrong. I'm just saying, like, what about it?
The sides.
They intersect.
This
at
is
a
this side.
four.
Yeah, and then the other side.
Oh, those would be what?
Parallel.
Parallel.
Damn it, I said the wrong one.
So those are parallel, but right here,
They intersect at a nearly degree.
okay? What about this wall to the floor? What kind of situation is that? Is that parallel or perpendicular?
Yellow.
Wall to floor. What is it? Perpendicular because it's making a 90, hopefully, right? Okay, here's the thing. Like, joking aside, both of these words start with P, so it's easy to get them mixed up. But they are completely different, like, in fact, complete opposites of each other. And so if you do get the words mixed up, you're going to get the math mixed up, and you may as well just not do the problem, right? Because it's a complete different process. Do you come across parallel lines in your daily life? Besides things like borders of doors and stuff. Parallel. Listen carefully, right?
The legs on these chairs. I mean, pews.
Look at them. Are they parallel?
Yes.
No, they're not. Look at them. Jack.
Yes.
You guys, I'm asking the class in general. I'm not sure why we're having all these side conversations. Tell me about it.
The lines that keep you in place are usually parallel.
They should be pretty close. They're not perfect, but that's the concept of it, right? So lane lines on the road should be parallel. Parallel, not perpendicular, right? Okay. How about the two lanes, like out here on Highway 50? We're driving, or whatever that highway is out there. The business loop. Two lanes going together. The lanes themselves would be parallel, right? And then when you get to an intersection, what do you run into there? What kind of lines would our lanes be at an intersection? Most likely. Say it.
Perpendicular.
All right. Good. All right. Let's see if you can tell me the relationship in the slopes of perpendicular lines. They are different. Here's those. We're going to zoom in here on the orange and the black line. So hopefully you can look at this and see that this is 90 degrees. That little box is the symbol that tells us it's 90. So those are perpendicular. Let's find the slope of the black line from these 2 points right there. So what's that slope? And make sure you get the sign correct. Down to over 6. Is that fully reduced?
No.
Down 1 over 1/3.
Okay. So that slope is negative 1/3. Is the orange line going to have a slope of negative 1/3?
No.
No, because they're not parallel, right? That's the only time that has the same slope as if they're parallel. So let's find the slope between these 2 points. One, two, three, 4, 5. Something is wrong because that is not the right relationship. Is it even going through that? Yeah, it looks like it is. How about this one? All right, something is wrong with the orange line. 4, 0. 1, 2, 3, 4. 6, 5. Is that point on there? 5, 6, 1, 2, 3, 4, 5. Yeah, that's good. So did you guys count right down here? 1, 2, 3, 4. No, you counted wrong on that one. Jeesh.
Jeez.
That's why it says.
All right. That's better. Okay. Now let's do these two. What's the y? Change in y.
They're opposites.
Okay. What do you notice about those two numbers? There's two big ideas here. What do you notice about them? They're flipped and yeah, one is the opposite sign of the other. So we have enough time to squeeze this in. Grab your note and write it. We'll come back to it tomorrow. Start writing, stop talking. Class is not over yet. Jackson, can you stay after, please?
Yes.
Okay, they have to be opposite sign. If one is positive, the other's negative. If the given one is positive, the one you solve for is negative, and vice versa. And then the second thing is that it has to be the reciprocal, which means it's flipped over. We're going to put some examples tomorrow. Right there.